HallusionBench. You see what you think, or you think what you see. An image context reasoning benchmark. Challenging for GPT-4v, ision, Lava 1.5, and other multi-modality models. Large language models, LLMs, after being aligned with vision models and integrated into vision language models, VLMs, can bring impressive improvement in image reasoning tasks. This was shown by the recently released GPT-4v ision, Lava 1.5, etc. However, the strong language prior in these state-of-the-art, SOTA, LLMs can be a double-edged sword. They may ignore the image context and solely rely on the even contradictory language prior for reasoning. In contrast, the vision modules in VLMs are weaker than LLMs and may result in misleading visual representations, which are then translated to confident mistakes by LLMs. To study these two types of VLM mistakes, that is, language hallucination and visual illusion, we curated HallusionBench, an image context reasoning benchmark that is still challenging to even GPT-4v and Lava 1.5. We provide a detailed analysis of examples in HallusionBench, which sheds novel insights on the illusion or hallucination of VLMs and how to improve them in the future. The benchmark and codebase will be released at the project's website. DEsignBench exploring and benchmarking DALL-E 3 for imagining visual design. We introduced DEsignBench, a text-to-image generation benchmark tailored for visual design scenarios. Recent T2I models like DALL-E 3 and others have demonstrated remarkable capabilities in generating photorealistic images that align closely with textual inputs. While the allure of creating visually captivating images is undeniable, our emphasis extends beyond mere aesthetic pleasure. We aim to investigate the potential of using these powerful models in authentic design contexts. In pursuit of this goal, we developed DEsignBench, which incorporates test samples designed to assess T2I models on both design technical capability and design application scenario. Each of these two dimensions is supported by a diverse set of specific design categories. We explore DALL-E 3 together with other leading T2I models on DEsignBench, resulting in a comprehensive visual gallery for side-by-side comparisons. For DEsignBench benchmarking, we perform human evaluations on generated images in DEsignBench Gallery, against the criteria of image-text alignment, visual aesthetic, and design creativity. Our evaluation also considers other specialized design capabilities, including text rendering, layout composition, color harmony, 3D design, and medium style. In addition to human evaluations, we introduce the first automatic image generation evaluator powered by GPT-4v. This evaluator provides ratings that align well with human judgments while being easily replicable and cost-efficient. A high-resolution version is available at project's website. FreeNoise, tuning free longer video diffusion via noise rescheduling. With the availability of large-scale video datasets and the advances of diffusion models, text-driven video generation has achieved substantial progress. However, existing video generation models are typically trained on a limited number of frames, resulting in the inability to generate high-fidelity long videos during inference. Furthermore, these models only support single text conditions, whereas real-life scenarios often require multi-text conditions as the video content changes over time. To tackle these challenges, this study explores the potential of extending the text-driven capability to generate longer videos conditioned on multiple texts. 1. We first analyze the impact of initial noise in video diffusion models. Then, building upon the observation of noise, we propose FreeNoise, a tuning-free and time-efficient paradigm to enhance the generative capabilities of pre-trained video diffusion models while preserving content consistency. Specifically, instead of initializing noises for all frames, we reschedule a sequence of noises for long-range correlation and perform temporal attention over them by window-based function. 2. Additionally, we design a novel motion injection method to support the generation of videos conditioned on multiple text prompts. Extensive experiments validate the superiority of our paradigm in extending the generative capabilities of video diffusion models. It is noteworthy that compared with the previous best-performing method, which brought about 255% extra time cost, our method incurs only negligible time cost of approximately 17%. Generated video samples are available at our project's website. Exploring the boundaries of GPT-4 in radiology. The recent success of general domain large language models, LLMs, has significantly changed the natural language processing paradigm towards a unified foundation model across domains and applications. In this paper, we focus on assessing the performance of GPT-4, the most capable LLM so far, on the text-based applications for radiology reports, comparing against state-of-the-art, SOTA, radiology-specific models. Exploring various prompting strategies, we evaluated GPT-4 on a diverse range of common radiology tasks, and we found GPT-4 either outperforms or is on par with current SOTA radiology models. With zero-shot prompting, GPT-4 already obtains substantial gains, approximately 10% absolute improvement over radiology models in temporal sentence similarity classification, accuracy, and natural language inference, F1. For tasks that require learning dataset-specific style or schema, for example finding summarization, GPT-4 improves with example-based prompting and matches supervised SOTA. Our extensive error analysis with a board-certified radiologist shows GPT-4 has a sufficient level of radiology knowledge with only occasional errors in complex context that require nuanced domain knowledge. For finding summarization, GPT-4 outputs are found to be overall comparable with existing manually written impressions. Branch-solve-merge improves large language model, evaluation and generation. Large language models, LLMs, are frequently used for multifaceted language generation and evaluation tasks that involve satisfying intricate user constraints or taking into account multiple aspects and criteria. However, their performance can fall short due to the model's lack of coherence and inability to plan and decompose the problem. We propose Branch-Solve-Merge, BSM, a large language model program for tackling such challenging natural language tasks. It consists of branch, solve, and merge modules that are parameterized with specific prompts to the base LLM. These three modules plan a decomposition of the task into multiple parallel subtasks, independently solve them, and fuse the solutions to the subtasks. We apply our method to the tasks of LLM response evaluation and constrained text generation and evaluate its effectiveness with multiple LLMs, including Vicuna, Llama 2Chat, and GPT-4. BSM improves the evaluation correctness and consistency for each LLM by enhancing human LLM agreement by up to 26%, reducing length and pairwise position biases by up to 50%, and allowing Llama 2Chat to match or outperform GPT-4 on most domains. On the constraint story generation task, BSM improves the coherence of the stories while also improving constraint satisfaction by 12%. Ensemble-Instruct, generating instruction tuning data with a heterogeneous mixture of LMs, using in-context learning, ICL, for data generation, techniques such as self-instruct, Wang et al., 2023, or the follow-up alpaca, Taori et al., 2023, can train strong conversational agents with only a small amount of human supervision. One limitation of these approaches is that they resort to very large language models, around 175 billion parameters, that are also proprietary and non-public. Here we explore the application of such techniques to language models that are much smaller, around 10 billion to 40 billion parameters, and have permissive licenses. We find the self-instruct approach to be less effective at these sizes and propose new ICL methods that draw on two main ideas. A. Categorization and simplification of the ICL templates to make prompt learning easier for the language model. And B. Ensembling over multiple language model outputs to help select high-quality synthetic examples. Our algorithm leverages the 175 self-instruct seed tasks and employs separate pipelines for instructions that require an input and instructions that do not. Empirical investigations with different language models show that 1. Our proposed method yields higher quality instruction tuning data than self-instruct. 2. It improves performances of both vanilla and instruction-tuned language models by significant margins. And 3. Smaller instruction-tuned language models generate more useful outputs than their larger untuned counterparts. Our codebase is available at the project's website. Specific versus General Principles for Constitutional AI. Human feedback can prevent overtly harmful utterances in conversational models, but may not automatically mitigate subtle problematic behaviors such as a stated desire for self-preservation or power. Constitutional AI offers an alternative, replacing human feedback with feedback from AI models, conditioned only on a list of written principles. We find this approach effectively prevents the expression of such behaviors. The success of simple principles motivates us to ask, can models learn general ethical behaviors from only a single written principle? To test this, we run experiments using a principle roughly stated as, do what's best for humanity. We find that the largest dialogue models can generalize from this short constitution, resulting in harmless assistance with no stated interest in specific motivations like power. A general principle may thus partially avoid the need for a long list of constitutions targeting potentially harmful behaviors. However, more detailed constitutions still improve fine-grained control over specific types of harms. This suggests both general and specific principles have value for steering AI safely. Localizing and editing knowledge in text-to-image generative models. Text-to-image diffusion models such as Stable Diffusion and Imagen have achieved unprecedented quality of photorealism with state-of-the-art FID scores on MS COCO and other generation benchmarks. Given a caption, image generation requires fine-grained knowledge about attributes such as object structure, style, and viewpoint, amongst others. Where does this information reside in text-to-image generative models? In our paper, we tackle this question and understand how knowledge corresponding to distinct visual attributes is stored in large-scale text-to-image diffusion models. We adapt causal mediation analysis for text-to-image models and trace knowledge about distinct visual attributes to various causal components in the UNet and text encoder of the diffusion model. In particular, we show that unlike generative large language models, knowledge about different attributes is not localized in isolated components, but is instead distributed amongst a set of components in the conditional UNet. These sets of components are often distinct for different visual attributes. Remarkably, we find that the clip text encoder in public text-to-image models, such as Stable Diffusion, contains only one causal state across different visual attributes. And this is the first self-attention layer corresponding to the last subject token of the attribute in the caption. This is in stark contrast to the causal states in other language models, which are often the mid-MLP layers. Based on this observation of only one causal state in the text encoder, we introduce a fast, data-free model editing method, Diff-Quick-Fix, which can effectively edit concepts in text-to-image models. Diff-Quick-Fix can edit ablate concepts in under a second with a closed-form update, providing a significant 1000x speedup and comparable editing performance to existing fine-tuning-based editing methods. InstructExcel, a benchmark for natural language instruction in Excel. With the evolution of large language models, LLMs, we can solve increasingly more complex NLP tasks across various domains, including spreadsheets. This work investigates whether LLMs can generate code, Excel office scripts, a TypeScript API for executing many tasks in Excel that solves Excel-specific tasks provided via natural language user instructions. To do so, we introduce a new large-scale benchmark, InstructExcel, created by leveraging the Automate feature in Excel to automatically generate office scripts from users' actions. Our benchmark includes over 10K samples covering 170-plus Excel operations across 2,000 publicly available Excel spreadsheets. Experiments across various zero-shot and few-shot settings show that InstructExcel is a hard benchmark for state-of-the-art models like GPT-4. We observe that 1. Using GPT-4 over GPT 3.5, 2. Providing more in-context examples, and 3. Dynamic prompting can help improve performance on this benchmark.